On the board, you'll see a scenario I'm describing, which is you going to the carnival that comes into town to try and get a job. Nah, just kidding. To go there and eat too much junk food and play silly games with darts and balloons. So, the scenario is it costs you $4 to get into the carnival, and then it costs you $2 per game. So, how much money did you spend that night? There's no way to know. What do you need to know? What piece of information are you missing to know how much money you spent that night? Do you need to know how many times you entered the carnival, or do you need to know how many times you played a game? Well, I've never been to a place where you have to pay to get in more than once. So you're just going to spend that $4 once to get in. That's the piece of information you need. How many games did you play once you were in there? Say your parents gave you $10. You could have played 3 games. $4 to get in, $2 per game. That's another $6. There goes your $10 down the drain when you could have bought something nice for your teacher. Okay, so what my point is that to know how much money you spent that night, you got to know how many games you played. We're going to turn this into an equation so that you can figure out right away how much money you spent depending on how many games you played. To do that, we're going to need 2 variables. We're going to need to use the letter y, which is going to represent the total money that you spent that night. So for instance, if you played 3 games, you spent $10. If you didn't play any games, you only spent $4. So we need a variable to represent how many games you played. We're going to use x for that. So x is games played. Now, we want to know ultimately how much you spent that night, so y is going to equal some equation. So on the left-hand side, we're going to have y, the total amount you spent, is going to be equal to the amount of games you played times 2, because it's $2 per game, plus the $4 it cost you to get in, right? If you played 3 games, that's $6 in games. 3 times 2, plus the $4 it costs you to get in there. 6 plus 4 is 10. So that's our equation. I just talked it out. You can imagine how you would figure in your head what it took to spend $10. If I said you spent $10 that night, how many games did you play? I think most of you could say I played 3 games. You can do this math in your head. It's putting it into equation that seems intimidating and difficult, but it's really not. Just think about what you're doing. You're saying the amount of games I play, I'm multiplying that by 2. So it's 2 times x, 2x. If you played 3 games, 2 times 3 is 6. If you played 4 games, 2 times 4 is 8. It's the $2 multiplying by x. The reason we know this is multiplying is there's not a plus or minus in between our number and our variable. So this is 2 times that variable. And that variable represents the games we played. So y equals 2 times x, $2 per game, plus, don't forget about, plus the $4 that it cost you to get in. Even if you don't play any games, even if this is a 0, you spent $2 on nothing. 2 times 0. That means you didn't spend anything. You didn't spend any dollars on games, but you still got that $4 to get in. So you still spent the $4 even if you don't play a game. Let's say you get crazy and you're just winning all these teddy bears like a champion, and you play 10 games. Well, that means you spent $20 on games. 2 times 10 is 20, plus the $4 to get in. You spent $24 that night for 6 giant teddy bears. Maybe that was a good deal. I don't know. Okay, what this is right here is on the front cover of your book. This is the most probably important equation of the year in algebra, and it is this equation right here. Bye-bye, Carnival. It was fun. Now it's time to get into some real algebra here. Y equals mx plus b. Ooh, that's a terrible b. Hopefully you guys have seen this before. Y equals mx plus b. If you have not seen it, you don't even have to open your book. If you just look right on the cover, and it's the only equation on the cover, that might give you some kind of hint on how important it is. And this is called the Slope-Intercept form or equation. I'll call it form because there's different ways to jumble these around. So it's in the form of slope-intercept. And you use that for like real life business problems, like how much did you spend on something, or how much does the company make if we sell 20 cars? How much do we make if we sell 50 cars? All right, so this actually, people say, when am I ever going to use this in real life? Well, pretty much any job you get, you're probably going to see this in some form or another. Slope-intercept form. Why is it called slope-intercept form? Let me go back to the carnival problem. Let's say we wanted to represent how much money we could spend at the carnival on a graph. We would draw a little XY graph, x-axis, y-axis, and the y represents the total money spent, and the x represents the games we played. And if you don't even play a single game, you spent $4. So if you play 0 games, you spent $4. Because remember, it costs $4 to get in. So that dot right there represents 0 on the x-axis. We're still right at the origin, going straight up. That's the point 0, 4. That means you played 0 games. X represents games, and you spent $4. The y coordinate of that point represents our money. You play 0 games, you spend $4. Let's say you play 1 game. That would be over here, 1 on the x-axis. Now we're moving to the right. Now we're playing some games, people. If you play 1 game, you spent $6, the 0.16. If you play 2 games, you spent $8, 2, 8. 3 games would be $10, 3, 10. You get the point here? And look, those points are all on the same straight line. Now on the last test, we found rate of change. You could put these points into a table. You could say X is games played. If we don't play any games, we spend $4. If we play 1 game, we spend 6. 2 games is going to cost us 8. $3, we spent $10. Or 3 games, spent $10 that night. So on and so forth. What's the rate of change here? You could go between any 2 numbers here, and it's 2 and 1, 2 and 1, 2 and 1. That's the rate of change, 2 over 1, but it's special. It is a constant rate of change. That means it's not changing. It's not like we play that 4th game and all of a sudden that 4th game cost us $5 to play that game. We didn't go to 4 games up to $15. Games don't get more expensive as the night goes along at this carnival. You got that going for you. They're constantly $2 each. It's a constant rate of change. You're constantly spending $2 more every game you play. So that's a special kind of rate of change that we didn't really see on that last test. The last test, the numbers were all over the place, and you just had to find out what was the rate of change between any given 2 of them. Now that we're into a slope-intercept form, the rate of change is the same. It stays constant. And when it's constant, we call it slope. And we represent slope with the letter M. So this M right here is slope. That's our rate of change, but it's constant, so now we call it slope. So that's where we get half of the name of this equation from. And then the B, the intercept, they're talking about the y-intercept here. They're talking about where does this graph cross, where does it intersect, where does it intercept the y-axis? Well, it intersects the y-axis when x is 0. Because any point, you could pick any point on this y-axis. That might be 0, 8. We could pick one down here. This might be 0, -2. It doesn't matter what point you pick on the y-axis, the ordered pair for that point is going to be 0 some number. Because you're not moving left or right. You're going 0 spaces in the x direction. You're just going up or down. You're just moving in the y direction, up or down that many spaces. So if you want to know what the y-intercept is, you just see where your line crosses the graph, or you look at your table, and wherever your 0 is on the x column, straight across from there is your y-intercept, 4. 4. So B in this case was 4, the y-intercept. So that's where the name comes from. You have an M for slope, you have a B for y-intercept, and those numbers, slope is your rate of change. It's $2 per game. B is your y-intercept. That's your constant. That's the amount that doesn't change. It doesn't matter how many games you play that night, you're spending that $4 to get in. All right, that's the constant. It's not like you're going to have to spend that $4 more than once. That's just a number by itself. So the equation for this carnival problem was y equals 2x plus 4. 2 was the slope. 4 was the y-intercept. This is your introduction to slope-intercept form. This is what it all means. I know it looks confusing, but if you think of that carnival problem, you guys can understand that carnival problem in your head. It's easy to figure how much you spent. If you spent $4 to get in and $2 per game, you just have to understand this is just representing that. This table, this graph, this equation is all representing that story about the carnival. 3 different ways to represent it. Represent it in a table, you can represent it in an equation, you can represent it in a graph, but it's all saying the same thing. It's all saying, I spent $2 per game that night plus $4 to get in. And the y column, or the y variable, or the y coordinate in your points is all the total amount you spent that night. The x is how many games you played. If you played 1 game, you spent $6. If you played 3 games, you spent $10. 1 game, $6. 3 games, $10. You want to know how much you spent on 1 game? You plug a 1 in there. Y equals 2 times 1 plus 4. That's y equals 2 plus 4. That's y equals 6. So any one of these will tell you that if you played 1 game, you spent $6. Plug a 1 in for x, you get y equals 6. What you're going to be asked to do for this standard predominantly is to match up equations with graphs. All right, so let me show you a trick on how to do that. Let's say they give you this graph right here. 1, 2, 3, 1, 2, 1, there's another point. 1, 2, 1, there's another point. So let's say that's our graph. This is the point 0, 3, this is the point 2, 4, and this is the point 3, 4, 5. Over 4 of 5 people. Third person, me. Okay, so those are the 3 points they give you. That's the graph they gave you and say, okay, there's your graph, turn that into an equation. You're going to be like, what? I don't see an equation there. How am I supposed to do that? Well, your equation is y equals mx plus b. And to turn that into an actual equation that represents this, you got to find numbers for m and b. Your answer is going to be y equals something x. I'm leaving a little blank spot there. You got to fill in this blank. What is m plus another blank spot? What is b? What is m and what is b? If you can figure out what m is and what b is from this equation, from this graph, and plug it into those spots right there, you're done. You've just written the equation for this graph. B is the easy one. B is your starting point. Technically, it's the y-intercept. I call it the starting point. That means start from that spot. Start when x is 0. What does y equal when x is 0? Where is this line crossing the y-axis? Well, when x is 0, y is 3. This line is crossing the y-axis at 1, 2, 3 spaces up, 3. So B is 3 in this one. The slope is the same way I taught you how to find rate of change on Thursday last week from a graph. You count up and over from one point to the next. Remember, rise over run? That's not going away either. Rise over run. You're still going to use that. So you start from the starting point, 3, and you count how far up and how far over from that point to the next one. Well, to get up from 3 to 4, we had to go up 1 space, and to get over from 0 to 2, we had to go over 2 spaces. So we rose 1 and we ran 2, 1 over 2. That's your slope. M is 1/2. You figured out what m and b are from this graph by starting from the y-intercept, starting from your starting point, and going up and over from there to the next point. 1 up 1 over 2. So you plug in 1/2, because that's M, and you plug in 3 for B, and you're done. You just wrote an equation for that graph, like magic. You're geniuses. And that's all you got to do, people. Find M and find B. Start with B. That's the easy one. B is on the y-axis. And then from there, count up and over. Find the rate of change. It's constant. It's slope. It's rise over run. It's just like last Thursday. Up and over. That's your slope. That's your equation. You're done. You don't have to worry about plugging in numbers for x and y. Just plug in a number for M and B, and you've matched an equation to a graph. So that is what the work is like today. You got to match the equation to the correct graph. You also have to, well, I'll save that till tomorrow. For today, all you got to do is match the equation to the graph, and then we'll take it from there tomorrow.